Kia ora Year 12 and Year 13. This is today's starter on implicit differentiation. So I'm recording this because there are 7 of you away at the choir thing, but also because we're going to need implicit differentiation for the next 2 weeks of scholarship calculus, and it's a core skill for A-level, so I thought we might as well go back and have a look at it. So there are 4 questions here. The 4th one is what I'd call kind of messy and challenging. The other ones are pretty straightforward applications of the chain rule. So if you need to, go back at home when you've watched this, if you're a bit lost, and watch the 3 teaching videos on implicit differentiation. You can just search them up. So the basic idea is that we're doing the chain rule and we're going to differentiate with respect to either x or y and then just chain rule each problem out. So with this first one, x squared plus y cubed equals 8, we look at the first term and we differentiate with respect to x. That gives us 2x. We look at the second term and we can't differentiate with respect to x, but we can differentiate with respect to y. And then we multiply through by dy by dx, right? So that's using the idea that we are doing this. So we're differentiating y cubed with respect to y, and then we're multiplying by dy by dx. So it's a straightforward application of the chain rule. When I differentiate a constant with respect to x, I get 0. All I have to do now is rearrange, and I get dy by dx is equal to, so let's go very slowly, 3y squared dy by dx is equal to negative 2x. And then dy by dx is equal to negative 2x over 3y squared. And you'll see once we start doing problems where we need to apply the derivative, for example, finding a tangent or a normal or something, we don't always need to go this far through. Sometimes we can work with whatever equation we've got up here. But in this one, I've asked you for dy by dx, so that's what you need to do. Now, the next one I've put in, because when we start looking at conic sections, you'll see that this is quite kind of similar to what we're going to do with ellipses and hyperbole. And it's got an x minus 4 in it instead of an x, and a y minus 5 in it instead of a y. So let's just start by writing that out. And I think if you just remember your chain rule from AS or early level 3, this is not too bad at all, right? We don't have to expand this out, and we don't have to expand this out. We get 2 times x minus 4 when we're differentiating with respect to x, plus 3 times y minus 5 squared dy by dx is equal to 0. Rearranging that, I'm going to go quickly with this rearranging because I'm teaching in about 5 minutes. So dy by dx is equal to negative 2 x minus 4, that's from subtracting that from both sides, divided by 3 times y minus 5 squared. So there's that one finished. Okay, number 3 is to give you just a tiny bit of remembering your trig derivatives, because I know you all are so fond of trig at the moment. So e to the x minus sine y is equal to x. So we just differentiate each term with respect to x. E to the x differentiates to give me e to the x. Here, we differentiate with respect to y, and we get negative, take away cos y, and then we have to multiply by dy by dx, and here we get 1. Rearranging gives me negative cos of y dy by dx, that's nothing there, put my brackets back in, equals 1 minus e to the x. So dy by dx will equal, I'm going to divide through by negative cos y, so I can go, hopefully by now you guys can all do that quickly. So there's the third one done. Right, now the last one is going to take a couple of minutes. The last one is kind of messy because we've got a chain rule inside a chain rule. So let's have a look at it before we start. Well, we've got tan of a thing. Now the derivative on the outside is going to be sec squared, but in here we're going to have to do the product rule to find the inside function's derivative. And then this bit here is not too bad at all. Okay, so let's use the space here. I'm going to do this without explicitly doing a u substitution. If you want to go a bit more slowly, that's fine. So on this side, we've got sec squared of the inside stuff times the derivative of my u, basically, so x squared y to the 4 with respect to x. So we'll just park it like that for now. And over on the right-hand side, we get 3 plus 2y dy by dx. This should be feeling easy now. Right, what's next? Well, I need to get on with it and differentiate the inside thing. So we're going to have sec squared sec squared of x squared y to the 4 times, right, the first function times the derivative of the second one. So this will be 4y cubed dy by dx plus the other way around, 2x times y to the power of 4. And that equals 3 plus 2y dy by dx. Now we've done the thinking part. What we've got to do now is just carefully collect up the like terms that have got dy by dx in. So we're going to have 4x squared y cubed, 6 squared x squared y to the 4 dy by dx plus 2xy to the 4 6 squared times of x squared y to the 4. And over here we've got 3 plus 2y dy by dx. We just have to rearrange a little bit and then divide things through. So the pathway should be clear, but it's easy to make small mistakes here. So I'm going to subtract this from both sides, and I'm going to subtract this from both sides. That leaves me with dy by dx into 4x squared y cubed, 6 squared of that minus 2y is equal to 3 take away 2x y to the 4 6 squared of x squared y to the 4, giving me a final answer for dy by dx of this. Sorry for the stylus noise, guys. I think you've probably all hung up the video by now. There we are, and we're finished. Right, so just check that you haven't mucked that one up. Quite a lot of little steps in there. In the harder problems with implicit, you often will have to use the product rule. Okay, if you need more practice at that, there's heaps in the A-level textbook and also in Old Delta. Thanks for watching.